In this section, we're talking about area and volume and surface area. So we're going to look at the area of polygons and circles, and then the volume and surface area of some geometric solids. There's quite a few notes to take in this one because there's a lot of formulas for the different shapes. So first, let's talk about units. What are some units of these different things? And I find that people get these confused. So remember, length is just measuring a distance. So that's going to be something like centimeters or inches or miles or feet, things like that. Area is measuring 2 dimensions. Okay, so it's length times width, or the area of a circle. So these are always going to be squared. So we get things like centimeters squared, inches squared, miles squared, and yes, you can have square miles, and feet squared. So we say usually square miles and square feet, or square inches, or you say inches squared. Volume can be centimeters cubed because we are looking at how much stuff something holds. And so we have to measure in 3 directions: length, width, and height, 3-dimensional. So cubic centimeters or centimeters cubed, inches cubed, and so on. And yeah, you can have cubic miles, and that's a very large space, and feet cubed. Okay, so very different types of measurements: length, area, and volume, and they have different units. So first, we're going to be looking at the area of plane figures. That means a 2-dimensional space that's like flat on a piece of paper. You can just draw it flat on a piece of paper. So these 3 you need to know, so I would definitely have them in your notes. A square is the side, so this is just S here, S squared, because both sides are S. So if you multiplied them together, it would be S squared. The width times the length is a rectangle, because if it's a rectangle, it means that the width and length are 2 different dimensions, so they have different numbers. If they're the same, it would be a square. So it's the same idea. They're both the same thing. It just so happens that in a square, the 2 sides are the same. In a rectangle, you just get 1/2 the base times the height. And I could go into showing you how really it's half of a rectangle. So it's basically just, if you took this thing and rearranged it, you would find that it makes half of a rectangle. So it's 1/2 base times height. All right, so we're going to look at the area of each of these figures using these equations. So the first one is a square, and the area of a square is just side squared. So area equals the side squared, which equals 4 centimeters squared. So that is going to give us 16, and don't forget to put the unit on, centimeters squared. If I'd put the centimeters in here, if I had said 4 centimeters and squared it, both the 4 and the centimeters squared. So if you have a hard time keeping track of units, you can do that too. All right, in B, we've got that the area equals length times width, okay, because it's a rectangle. And by the way, these symbols right here mean that the double and the single dashes mean that the single dashes are equal in length, and the double dashes are equal in length. We've got the same thing here in the square, so that's how they show you without telling you it's a square. That's how they show you that it's a square. All right, so we've got length, which is 6. And if you want to use the units, I'll use it a couple of times. It makes it kind of messy, but just to keep track of your units, you can do that if you'd like. And the width is 2.5 centimeters. All right, so we get 2.5 times 6, and that gives us 15. And centimeters times centimeters, that's centimeters squared. Okay, so, or you can just remember that the units should be centimeters, and they should be squared because it's an area. Okay, the next one, we've got area equals, now this is a triangle, so 1/2 base times height. Okay, so we're going to do 1/2. The base is 15 feet, and the height is 8 feet. So we get 1/2 of 15 times 8. And instead of saying 1/2 of 15 times 8, I'm just going to do it all at once, which you can do in your calculator. You can say 15 times 8 divided by 2, or you can say 0.5 times 15 times 8, and you should get 60. And you've got feet times feet, so you get feet squared. All right. So I did not have try-its for those last three problems because I feel that they are a review for most people. We're going to move on to parallelograms. So I have an animation here to show you the area of a parallelogram, and I want to show it to you this way because a lot of people don't understand how simple this area formula is, and this hopefully will make it easier to remember. A parallelogram has opposite sides that are parallel to one another, so that ends up making the opposite sides equal in length, but all four sides do not have to be equal in length. So watch this. We have, if you do a right angle up here at the top on one of the sides and create a triangle, so this right here is a right angle. If we take that triangle and we scoot it over to the other side, we end up with a rectangle. So the area is just the base times the height. And if you want to go into this OneNote page for 8.5, you can play with it as well. So, all right, so the area of a parallelogram is base times height. Okay, and remember that the height of the shape is not the length of the side. It is at a right angle to one of the sides, and then the other length is perpendicular to it. Okay. So I don't have one for you to try. If you would like to try this one before I do it, this is the only example for a parallelogram, so give it a shot. Pause the video and come back and watch me do it. Okay, so the area for a parallelogram, like we said, is area equals base times height. And notice that the height here, they should have put a right angle there. But to show you that that's definitely the height. It can only be the height if it's at a right angle to the base. So the base is going to be 20. And the height is going to be 12. And notice this time I left the units out, and I will just put them on at the end. And you get 240 miles squared. By the way, in a science class, you want to keep the units on throughout the whole thing in most classes. All right. Okay, this next one is the area of a trapezoid. So a trapezoid, two sides are parallel, the other two sides are not parallel. So the height is always at a right angle to the base. Okay, so you've got a base here and you've got the top up here. So that's the length of this one is A at the top, the length of the bottom one is B, and the height is at a right angle to both. All right, so watch this. If you take the top and you flip it over, you get a new base of A plus B. Now you get a parallelogram. And this height right here is 1/2 of the original h. So I'll go back to that. 1/2. So here's the height. You split it in half and you bring it over. Now you've got a parallelogram. What is the area of a parallelogram? Think about that. It's going to be this new height, which is the original height divided by 2, times the new base, which is A plus B. So now we've got an area of h over 2 times A plus B. Another way that people write this is h, or 1/2 A plus B times h. But this is another way to think about it. So we decided that the area of a trapezoid is h over 2 times A plus B. A and B being the length of the bottom and the length of the top. Some people call it the two bases, but that's a little confusing. So the length of the bottom and the length of the top. Another way to write this is 1/2 A plus B times h. All right, so let's try this with this next example. And again, I don't have a try it for you on this one right now. I've got a bunch at the bottom. So if you want to pause and just see if you can do it and get the right answer before I do it, go ahead and pause the video now. Okay, so the area of this is going to be the height divided by 2 times A plus B. So that's the one I'm going to be using. So we've got 6 is the height divided by 2 times 5 plus 8, 5.8 plus 8.2. And so we get 6 divided by 2 is 3. And 5.8 plus 8.2 is 14. And when you multiply those together, you get 42. And don't forget to put the unit on it. So go back and look. It's feet, and it's an area, so it's feet squared. Heat squared. Okay, next I'm going to show you, some have never seen this, where the area of a circle comes from. And this is pretty brilliant if you can imagine coming up with this yourself, but they have divided this into triangles. And the triangles that we're using here are big enough to see. But if you just imagine that these triangles keep getting smaller and smaller, and there's just more and more of them until there's like millions of triangles in here, and then this curve would smooth out. Okay, so watch what happens when we take these triangles out and then slide them together. What do we get? That is a parallelogram. And what is the length of the base? Think about the length of the base. I'll back it up. The length of the bases is a half of the distance around the circle. So the mathematical thinking is here. And again, you can go look at this one note yourself and go through this to see exactly all the different parts of it and play with it a little bit. But they closely approximate the actual circle. They're rearranged to form a parallelogram. And then the base of the parallelogram is half the circumference. Half the circumference. And then the height of the parallelogram is the radius of the circle. And then the area of the parallelogram is base times height. So if the base is pi r and the height is r, then we end up with a formula of pi r times r, which is pi r squared. Okay, so that is the area of the circle. And that's where it comes from. Okay, so the area of a circle is, as we just saw above, pi r squared, where pi is approximately equal to 3.14. And it's also approximately equal to, and that's what this little squiggly line means, remember? It means approximately equal to, not exactly equal to, 22/7. So depending on the situation, and if you're given fractions or whole numbers or decimals, you can use either one of these pi's. All right, so let's find the approximate area of each circle using 3.14 for pi. So that's what we're asked to do, 3.14. So they don't want an exact answer, they want it approximated. So we're going to say for A, the area equals pi r squared. And I can't say how important enough it is to start with a formula. It just makes things so much easier. And r equals 9. Okay, so this isn't D, this is r, so make sure you've got that straight, pi r squared. So we're going to say pi times 9 squared. So we get 81 times pi, which is 3.14. 81 is 9 squared times 3.14. Sorry, I changed the order of these because that's just my habit to always put the number first. And then you're going to get, when you multiply this out, 254.34, and it's centimeters, and they are squared. All right, the next one. So we've got, right here, we've got, this is a diameter, so 5 feet. So what is the radius? The radius is 2.5 feet. So make sure you do that first. And the area is pi r squared. So we get pi times 2.5 squared, which is 3.14 times 2.5 squared. And you can just put that in your calculator. I don't recommend working out little bits as you go because people have a tendency to write things down wrong or put them back in their calculator wrong. Just put it all in your calculator all together. 3.14 times 2.5 squared, or times 2.5 times 2.5 if you don't have a scientific calculator. All right, so you should get 19.625 feet, and they are squared. Now it's your turn to try it. I've got 3 different shapes here. Pay attention to which ones they are and what the formula is going to be for each, and you may want to go back and look at your notes. So pause the video and try these and come back and see if you got them right. Okay, so the first one is a parallelogram, and we're going to just use base times height to get 450 centimeters squared. The second one is a trapezoid, so we're going to use the b over 2, or 1/2 times b, a plus b, and you should get 259 feet squared. And the last one, don't forget to change the diameter to the radius. So divide it in half and get 17.5 feet. So this one would give you 17.5 feet. And you should get 961.6 square feet. So the second topic here is finding volume and surface area of geometric solids. So remember, volume and surface area are two very different things. So work hard to keep them separate from one another. Volume is a measure of the amount of substance needed to fill a space. So if it could hold liquid, how much liquid would it hold? And it's measured in cubic units, like I talked about before. While surface area measures the amount of exposed area for a given solid. In other words, what is on the outside, what you can touch. And it's an area because it's just a flat surface, and it's measured in square units. So these are the formulas that you need to know. So these are the volume and surface areas for a whole bunch of different things, and I'm not going to go through them all individually. But you just need to have these somewhere where you can find them in your notes or here in OneNote. You can come back to OneNote and you can copy and paste it into your own notes or however you'd like to work that. So I'm going to work through this, move it down, and you can pause this and take a look. Okay, so for example 5, we're going to find the volume of each of these geometric solids. And if we're using a circle, we are supposed to use 3.14 to approximate for pi. And we are also supposed to round to the nearest tenth. So pay attention to those things, especially when you're doing MyLab, it will count the entire problem wrong. Okay, so the first one is a circular cylinder. So we need to go find and we're looking for volume, not surface area right now. So we're looking for volume of a circular cylinder. Circular cylinder looks like this. It's got a radius, it's got a flat bottom and a flat top, just like a can. So think about a can. And there's a height. So the volume is going to be pi times the radius of the bottom or top squared times the height. Okay, so let's look at writing that down. So for A, we've got volume equals, and like I said, use your formula first. Always write it down first. Don't just jump into trying to use the numbers. So especially for these, because there's so many different formulas. Pi r squared h. Make sure you've got everything before you get going. So we've got pi. R is 3 feet. So we've got 3 squared, and h is 12 feet, so we've got 12 here. So we've got pi times 9 times 3 at 12. So just put this right into your calculator. 3.14 times 3 squared, which is 9, times 12. And you don't even have to know it's 9. You can just tell it to square it, and you should get 108 pi. If you're going to take a middle step, you get the numbers multiply to be 108. So I just wanted to show you that. If you go straight to the answer on your calculator using 3.14, you get 339, and we're supposed to only go to one decimal place, so 0.1 feet squared. Okay? So for the next one, we've got a rectangular prism. So what is the formula for a rectangular prism? So let's go up here and look. A rectangular prism is just like a box. So you're just going to take the length times the width times the height. So those are pretty straightforward. So the rectangular prism, we've got the length here, the width, and the height. So the volume equals length times width times height, which is 14 times 10 times 3. So 14 times 10 times 3 is 420. And don't forget to use your units. They are meters. So it's going to be meters cubed. Oh, and I messed up that last one. What did I do wrong on the last one? What did I do wrong? I said squared. And that is a volume. So it is cubed. So everybody does it. See, I did it too. Make sure you don't go back and double check. I am looking for volume. So my units need to be cubed. Okay, now it's time for you to try it. Hopefully you wrote those down, but you can go back in the video and look at it, or you can open your OneNote to section 8.5 and find those. If you could try these and pause the video and come back, read the instructions, and use the formulas, and I'll have the answers up in just a moment. Okay, so a cube is like a die. All sides are the same. So it's side cubed, 11 cubed, and you get 1,331 cubic inches. A cone, so let's go look at what a cone looks like. A cone looks like this, and the volume of a cone is 1/3 pi r squared h, where r is the radius of the big circle at the end, and the height is at a right angle and it goes right up to the tip of the cone. So it's also called a funnel. So you should get 235.5 centimeters cubed. My last example is finding surface areas of geometric solids, and the same deal, 3.14 for pi and round to the 10th. So the first one is a square-based pyramid. The square-based pyramid. So we need to figure out what the surface area is, and generally use S, or you can say SA for surface area. I find SA to be a little bit more specific because S stands for lots of different things. So SA or S. And let's go look at a square-based pyramid. So we'll go back up here. And a square-based pyramid, the surface area is the area of the base plus 2 times the side times the slant height. Okay, so make sure you understand what each of these variables is, so you can look down here to see what the descriptions are. S is the side, and L is the slant height. Okay, so the side is the length of a side here, and the slant height is the length of one of the sides from bottom to top. All right, and the base, what is the base? Well, the base is the side squared because it's a square-based pyramid. Okay, so we're going to write all that down. So the surface area is going to be, and I'm going to write it in both ways so you can see what it looks like. The base, the area of the base, plus 2 times S times L. The area of the base is S squared plus 2SL. Now remember, we're doing surface area, so this is going to be units squared, so be careful at the end. All right, so side squared is going to be 6 squared plus 2 times 6 times the length is 5. All right, so did we need the H? We did not use the H. It would be used if we were asked for the volume, so it was a little extra information in case the problem had 2 different parts to it, which I think it did, but I only gave you half of it. So we've got 36 plus 2 times 6 times 5 is 60, and that gives us 96 feet. Now think about it. Squared, cubed, what is it? Surface area, so it's squared. Okay, so that's the first one. All right, the next one is a sphere. So if we go up again and look at the surface area of a sphere, so S is the surface area, equals 4 pi r squared. So just 4 times the area of a circle, which is kind of crazy. So we get B is going to be the surface area of a sphere. So we get 4 pi r squared, which is going to be approximately, so here we change it to approximate because we're going to put 3.14 in for pi, and it is a number that goes on forever, so we've chopped part of it off, so this is just approximate. And we get 452.2 centimeters, and what's the unit? Should be squared. Okay, so that's how you're going to do the surface area problems. And again, you can just call it S instead of SA if you want to, and watch your units. So you're going to have one more to try, actually 2. So now you try it, do exactly what I just did for these 2 different shapes. This is a rectangular prism and this is a cube, so these are pretty straightforward. Okay, so here's how you work these problems. A rectangular prism, you've got to remember that we've got to look at every single face, and a prism like this has 6 sides. So we've got the 2 ends that are length times width, the 2 ends that are length times height, and the 2 ends that are width times height. So you've got to do each one of those, so 2 times each of those faces, and you get 18 meters squared. A cube, you don't have to do all that work. You just have to do one side and then multiply it times 6. So remember, it's like a die, it's got 6 sides, and so you're going to take the face and the area of it, which is side squared, and then take it times 6. So this one is 350 centimeters squared. All right, that is the end of this discussion, and thank you for watching.